Everyone, can you hear me properly? Hi, good, thanks. All right. So yeah, I'm not used to all the Ukamian procedures and stuff. So I just realized that, so we have this discussions that we should have about how I am to evaluate you. So and we should have had it like, I think before today, but yeah, anyways, decided now. So you have to say whether you agree or not with how the exams are organized and weighted. So from my perspective, I'm the benevolent dictator. So I decide as I think it's best for you, but I guess, so you have to say whether you agree or not. And then you have to vote on it. So yeah, let's just start by going back to, I'm just going to bring it to the, yeah, so. Here it is. So this is what we have to agree on. So I've just copied what was in the course outline. So yeah, so it's in French, but because that's for UCAM administration, but so it's the same thing. So there's going to be one homework which should be given back on March 7th, 20%, one exam in class 25%, and case studies 30%, and individual presentation 25%. So in my opinion, this should have more weight, since we're going to spend a lot of time on it. This is just trade theory and all the models we're going to see. However, since I'm giving a class to an audience with very various levels, then I don't know how familiar you are with economic modeling, with all the mathematics involved. So I figured it's best to give this a lower weight, but still give it some weight. So that's why we're going to have homework that is still 20%. So this is really to give you the chance to practice well for the exam. And then one exam just to make sure that you don't just decide to not come to class after the homework, thinking that all you have to do now is given the case studies and the individual presentations. Yeah, so here, let's have our discussion. So do you, do somebody have a comment on this, disagree about it? In some ways, I think it's fair. I don't know. No, so yeah, what I could say is, let's right, thing is, I don't know how many people are still in the class or not. So we could have a vote today. Maybe it's unfair for those who are not here, but at the same time, you should be here since it's class. Yeah, so anyways, I think this is okay, and people are going to agree with it. So or yeah, maybe I'll just give you some time, like so I don't want to put you on the spot and put you responsible for everything. So what I'm going to, but what I would like to do is have 2 volunteers. So since the class is online, so I cannot have you sign this agreement. So we should have should be signed by me and by other students. So obviously we cannot do that. So what they say is in case it's remote, like we are having today. So what I'm going to need is for 2 students to send me an email. And the email will be something like, yes, I agree with, so they give some text that that you should write in your email, and you send it to me and you say, I agree with this. So then I can just put your name there and then send that to the administration. So we have until the end of the month. So here's how I think I will do it. So yeah, maybe would 2 people be volunteer to just to write me this email among you?
I can write the email.
Okay, good, thanks.
It's just like one, I just have to write on behalf of the course, we agree with the syllabus. And
Yeah,
that's
yeah.
it.
So I can show you the text that you will have to write. That it's by the way, it's if you think it's unusual to have this, I agree with you. I've never never had this sort of procedure before, but yeah, here we are. Yeah, okay, I can paste it for you. Yeah, that's the sort of thing. Par la présente, je, and then your name, and then your code permanent. Confirme que la présente entente a été conclue. Yeah. So I guess, yeah, just in case you haven't had time to think too much about it. So what I have put up is a survey for the class. So please, before, let's say tomorrow, tomorrow at noon, please vote. Just say I agree or I abstain or I disagree, but hopefully everybody says I agree. And then when that's done, I will just write to you and say, oh, please send me this email so I can finish the thing. All right, I don't want to spend too long on it. So who said you agreed to send me the email?
I will send you the email.
Okay, so Alina.
I can do it too if you want.
Perfect. And who said that? Grégoire?
Yes.
So what's your last name?
Florian.
All right. So that's going to be out of the way. So so I'll just write to you when when the voting is done. So just let me just show you where the voting is going to happen. So it's on the Moodle website.
Sir, you know, like other courses, they just say how it's gonna be, and they just ask for two students to sign it. They don't really do a survey or whatever. It's more of like for the professor to not change how we going to evaluate us. That's it.
Okay.
It's not
Okay.
much of our opinion on how you are supposed to make the evaluation.
Yeah, I agree that it should. Okay, so
You
should
don't have to
should
worry. Yeah. Like other courses, they do way more than you, and we just like, okay, we're just going to sign it.
Yeah, no, I mean it's my first class at Pico, so I
Yeah,
don't
we
know
understand. But
that I want to do by the book, and they say that, but you know, I agree that at some point it's I decide I think what's best to teach you
Yeah.
as best as I can. All right, so anyway, so if I don't have too many people who disagree by tomorrow, then you can send me your email and I can get it over with. But in case you want to disagree or say whatever things, so the survey is, where is it? I put it up yesterday. Oh, can't find it. So, sondage, maybe it's this. I don't know. Well, I'll check it. Maybe I'll try to see where it went, but I thought there was a survey somewhere. Anyway, so no, let's stop wasting time on this. Okay. So yeah, let's just see it's fair. All right. So today we continue our, so I thought we would see Sherilyn, but I think it's, so yeah, before Sherilyn, there's just the factor model. But just before the factor model, I would like just to finish, not the whole exercise I gave you, but just two last small questions that I was asking last time. Just on the last model, and then we can up into the factor model. Let me find it. I have so many windows open. Okay. So we can just answer together, and then I can continue with the next. Yeah, I don't want to do it just because I forgot to give you a key piece of information. It's what was the global demand function, so you couldn't do it anyways, but these two you could do them. So or if you found it, then congratulations. I don't know how you managed to find it, but for what I'm planning to do is give you the the longer version answer, and then if you have questions about it, then I can go in class on it. And then I'm going to give you some of this sort of exercise to do on your homework assignment. Okay, so just to review what we were discussing last time. So Quebec produces wine and maple syrup. So it always takes ALM equals 2 hours to produce 1 liter of maple syrup. So this is A is their labor requirement, AL, and then M is for maple. Then 3 hours to produce 1 liter of wine. So if you remember, then what would be the relative price of maple syrup? So it's yeah, we had started answering this section. So I'm just going to show you what the answers were. So what you have to remember is that the wage is the same in both sector, and the wage is equal to the value of the marginal product of labor. So in that case, it's how much you sell 1 unit of maple syrup, but divided by how many workers or how long they need to work in each sector. And then, so when you want to compute then the relative price, it's just PM divided by PW, which and since the wage is the same, so you just get ALM divided by ALW, which is 2/3. And then we had answered this. This took a bit more work, so I'm just not going to spend too long on it. So just we were at C. So here in France, it always takes A star LM equals 6 hours to produce 1 liter of maple syrup. So yeah, and it always takes ALW equals 2 hours to produce 1 liter of wine. So it looks like they're pretty efficient at producing wine, and they're pretty inefficient at producing maple syrup. So I'm not going to influence you. So who has the absolute advantage in maple syrup? Is it in France or in Quebec? So here I give you 1 minute to think about it. Yeah, just going to, yeah, so now you can see everything. So these are the productivity in Quebec. These are the productivity in France. So who has the absolute advantage in maple syrup? So who is more productive at producing it? Who is better? When you have the answer, you can write it in the chat. I know it's hard for to just start your brain working in the morning, but do your best. Oh, I've got one answer, and it's the right answer. So I'm just, yes, 2 right answers. So I think, yeah, you're on the right track. So the right answer is, of course, I didn't even have to ask you. Of course, everybody knows that Quebec is better at producing maple syrup. But why is that the case? So Quebec has the absolute advantage. Why? Because simply ALM is smaller than A star LM. So in Quebec, only takes 2 hours of work to produce 1 liter. In France, 6 hours. Now, D, who has the comparative advantage in maple syrup? I've got good answers again. Yes, all right. So two ways to see it, and that's they are equally good. So one way is to look at how advantageous it is to produce maple syrup compared to wine in each country. So you would say something like ALM divided by ALW, which is equal to 2 divided by 3. And then you would compare this to oops, this is quite large again. A star LM divided by A star LW, which would be 6 divided by 2, which is equal to 3. So yes, so it means that 2/3 is smaller than 3. So the opportunity cost. So that's the way to think about it. So the opportunity cost of producing maple syrup in Quebec is smaller than in France. So that's really a notion of opportunity cost. Yeah, so some people have answered, have said, okay, so ALM divided by A star LM compared to ALW divided by A star LW. So that's an equivalent way of looking at it. You just have to flip the ratios around, but you get the same sort of answers.
So it works?
What?
So it works this way as well?
Yeah, if you look at another way of you looking at it is ALM divided by.
It was just to be sure because this is the way I did and I wasn't sure.
Yeah, so you get 2 divided by 6 and ALW divided by A star LW equals so what would that be? 3 divided by 2. So what that means is so producing wine in Quebec needs 1/3 as many workers or as many hours as in France, but producing maple syrup, but producing wine in Quebec requires 3 hours rather than 2 in France. So obviously the comparative advantage is in wine, is in maple syrup rather than wine. So that's so you just flip the ratios around and you get the same answer. So just if you write, if I were to ask you this, so you write it in this way or in this way, and you just explain what you're doing, why you're dividing stuff together, why it's important to do that, and yeah, and I would be very happy. All right, I can say that. And then so you didn't have all all you needed to answer it. I'm just going to show you what yeah, so what you must have is the global demand, the global relative demand to answer it. So you need the global relative demand. So that's Quebec plus France. And this is it. So I'm just going to paste it. So I'm not going to solve it because we have to start with the next chapter. But what I'm going to do is just rewrite this properly and post it. Leave you some time to think about it, and then I'm going to post the solutions. So you see how it's done. So because here I gave you the relative demand of wine in Quebec, and with this you were able to deduce how much would be produced of either good in Quebec. Then if we have trade between Quebec and France, then it means that the producers in Quebec and France are selling to both markets. There's no trade cost, obviously. So then what matters to know what the relative production is going to be is the relative demand for the global market. And here the relative demand is the quantity demanded, or here, yeah, quantity demanded of maple syrup in total, which is the quantity in Quebec plus quantity in France, divided by the quantity of wine demanded in total, which would be simply QW plus Q star W. So in this shape there is one way to have a demand function, because you see that higher the relative price, then the lower the relative demand. So if the price in maple syrup is bigger compared to the price in wine, then the quantity demanded of maple syrup will decline compared to the quantity of wine. So this is a sort of global demand that would look like this. Yeah, and so to answer this question, so you would have to go back to the supply and demand in the Ricardian model in the last class. I'm going to be upfront with you. It's not that easy. You have to think a bit about it. That's the goal. The goal is to give you some things that are not so obvious. And then, yeah, once you have thought a bit about it, I'm going to post the answers. All right. So that's all the fun we're going to have with the Ricardian model today. Okay. Sorry, I have like 10 windows open. It's just so many different exercises and sets of slides. Just looking for. Okay, I have it. Yes, good. All right. Anyways, I'm going to draw a lot of things by myself, because I think it's best for you to see how things are working. So if I just go over slides, it's kind of okay, but it would be even better, I think, if we. All right. Chapter 3, specific factors and income distribution. So it's this model is in some way more complex than the Ricardian model, because you have different factors that come in. In the Ricardian model, you have only one factor, labor. Here, you are going to have three factors: labor, land, and capital. So it looks more complicated, but in a way, it's less strange, because what happens with the Ricardian model is that since the relative prices of each good are always the same, then you get very extreme situations in which like either one country is going to specialize completely in one thing or the other is going to specialize completely in the other. And it looks, and then if you have countries with different sizes, it's kind of complicated to think about it. So here we're going to have things that look more natural in some ways, that look more like, that take into account the fact that the relative prices of things don't change dramatically, because you have changing marginal returns in different sectors as you invest more labor in one or the other. So that's what we're going to see here. All right, so yeah, so the specific factor model. So I'm just going to discuss a bit. So like this. So the source of trade here. In the Ricardian model, it was purely technological. Like in Quebec, we're good at producing maple syrup. In France, we're good at producing wine, and that's why you trade. Here it's going to be more complicated than that. So the source of trade is going to be difference in availability of specific factors which cannot be traded. So there is obviously no foreign direct investment, for instance. So because obviously, if you say, oh well, if some country has very little capital, so they have to concentrate their effort in agriculture. Fine, but it's always possible for other countries to say, oh, you don't have capital, but there's a great potential in your country. I'm just going to invest. So I'm just going to bring capital over. So that's not what's happening in this model. Here we're really looking at a more static, or in some sense a more short-term picture. Because of course over time you could bring capital, say to some other country, and you could have, so this the way that, so you could see things being more in equilibrium in the long term as there is more investment. And the best example of this is of course China, which benefited immensely from investment by advanced economies, say that by the United States, who sent their production there, so that before then the Chinese workers wouldn't have been able to use the American capital, but now yes, they're able to do that. Or another very important episode, but just to see if you you know your history. So do you know one other important episode of where capital was brought to some region just after World War II? It's a special plan by the US just after World War II.
Are you talking about when the US just bring all the gold after the war?
The gold, not necessarily gold, but yeah, actually they printed the American dollars rather. So they gave a lot of American dollars so that they could buy American goods or American investment goods. So what happened during World War II in terms of production capability? no, don't. Anyways, I don't want to spend too long on this because that's really a case where that's not the case. But yeah, what I had in mind is, so in World War II, all the capital or much of the capital in Europe, say especially in France and Germany, was completely destroyed. So the US said, let's have a Marshall Plan to rebuild Europe. So then they brought so many American funds, and then they could buy American investment goods and rebuild Europe thanks to that. So if Europe had to rebuild its own capital on its by itself, it would have been very long, but thanks to this, it was much faster. Yeah. So, but this, as you see, this is more long term. So here we're seeing just what happens in the short run when you have some specific region that has that is rich in some resource that would be capital or land to produce agricultural products. And then what happens if you open to trade? So just as just to give you some intuition, so let us just predict what will be the conclusion of the class. So then you have this in the back of your mind when we talk about the details, so you know what we're going with it. So imagine that so Canada is not open to trade. Canada has very little capital and a lot of agricultural land to produce agricultural product. So what will be rather expensive in Canada? Will it be manufactured good, or will it be agricultural product? I'm saying again my question. If Canada has lots of land to produce agricultural product, but very little capital to produce manufacturing good, so what is going to be more expensive? Just writing it down here. If Canada has less agricultural land.
Okay, is the agricultural products will be less?
Yes, little capital to produce. What will food or manufacturing so I'm just going to put relatively more expensive. And you got it right. Yeah, so manufacturing products. Now, second question, if Canada opens itself to trade with the US, which has more capital relative to agricultural land, how will the relative prices change in Canada? So I'm still talking about the price of manufacturing versus the price of food.
I think the price of food will going down because of the trade with the US.
So why do you think that? So you have one
because if the Canada trade with the US, all the product in Canada, some product will come from US and they are less expensive. So I think the Canadian will have those products at a less price.
Yes, so but look at what I wrote here. So in the US, they have more capital relative to agricultural land. So for them, it's easy to produce manufacturing products, and it's less easy to produce food. So as you see in Canada, it's easy to produce food and it's difficult to produce manufacturing products. While in the US, it's easy to produce manufacturing and it's expensive to produce food. So if Canada starts trading with the USA, which of the two products is going to become more expensive? Which of the two products is going to become cheaper relative to the other?
I think the manufacturing products will become cheaper and the agricultural will become more pricey. And then we might have equilibrium because they trade.
Yes, exactly. So result. So Canada will import manufacturing product from the USA and export food. So there's less excess food production in Canada since we can export it. So the price of the relative price will increase and relative price. So let me just of manufacturing products will decrease in Canada, of course. All right. And so this is exactly like what we would observe in the Ricardian model. It's just that in the Ricardian model, everything is very extreme because everything is linear. So here it's not going to be that extreme as we're going to see. It's a matter of relative productivity because of relative abundance. And so it's like Canada and the US will fuse together, and rather than having one region with more land and less manufacturing, the other with more manufacturing and less land. So you're going to have a more balanced composition of both. So both countries will benefit in that way, as we're going to see. All right, so this is the program. This I'm giving you the conclusion to keep in mind during the whole class. Yeah, so yeah, so this is what we're going to see. So a nice thing about this this model is that we're going to be able to discuss the income distribution and the gains from trade in each sector. Yeah. Because before it was kind of difficult because you only had one factor, workers, and they could really just shift from one sector to the other. But now we're going to really see that somebody who had a big farm in Canada and is going to be very happy being able to export, and somebody who had its capital in Canada is not going to be happy to see all the competition coming from the US. So we're going to be able to look at all these people individually. And then we're going to discuss the political economy of trade. Yeah, so all these things. All right. So this is the program. All right, so yeah, this is a bit saying what I've just said. So trade has some substantial effects in the income distribution within each trading nation. There are two main reasons why international trade has strong effect on the distribution of income. So resources cannot move immediately or costlessly from one country to the other. So this is true in the short run. In the long run, it's possible to import technology, it's possible to change things. So even the Ricardian model. So if Quebec has an advantage in maple syrup, but then for some reason we're able to export maple trees to France, then this advantage will change over time. So in the long run, who knows what can happen? Everything can happen. But in the short run, this is the case. And so industries differ in the factors of production they demand. So this is going to be the key. So obviously what we want to have is a model that is as simple as possible to allow us to understand what matters. Yeah. Yes. So it's the simplest model possible. If it violates your mind and you think, oh, it doesn't make sense, it's not exactly true, I agree, all models are not exactly true, but the goal is to give us some ways to discuss. Oh, sorry, I had this thing going on. Some ways to discuss in a non-trivial manner about all these things. All right, so let's go for it. So assume we are dealing with one economy that can produce two goods. So as I was saying, manufacturers and food. But I think in the model they were saying we have the US and Japan maybe, but let's just say that it's Canada and the US. Okay. So Canada has lots of land and not too much capital, and the US they have some land, but they have more capital compared to Canada in proportion. So you have now three factors of production: labor, capital, and land, which is going to be, so labor is going to be labeled L as usual. Capital is going to be labeled K, and land is going to be labeled T. Yeah, manufacturers are produced using capital and labor, but not land. So this is the crucial points that may look strange. You still need land to put your firm on to produce stuff. But to simplify our discussion, we're just going to assume it away. So we just say manufacturers need two things, labor and capital. And food need only two things, only labor and land, but no capital. Again, that's a simplifying assumption. But this is to allow us to look at things in a more simplified manner. So labor is the only mobile factor that can be used in either sector, and land and capital are both specific factors that can be used only in the production of one good. So again, land in food and capital in manufacturers. All right. And perfect competition prevails in all markets. So there's no shenanigans trying to affect the market prices. The market prices are every market participant takes market prices as given. Yeah. How much each good does the economy produce? Well, it depends on how much factor you have. So if you're in Canada, then it's quite cheap to produce agriculture and it's expensive to produce manufacturing goods, because we have the west of Canada that have big fields like Saskatchewan. So if you look at even the shape of the province of Saskatchewan, it just looks like a big field. So it's really good to produce corn there. But we still need manufacturing products in Canada. It's difficult to produce them. So we're going to have to pay more to produce them. Yeah, but still, so yeah. And the way we can realize what is going to cost more is summarized by a production function for both things. And especially by what we saw before, which is the production possibility frontier. But that time is going to be different from that the frontier we saw in the recording model. Yeah, so the production function for good X gives the maximum quantities of good X that a firm can produce with various factors, amount of factor inputs. And yeah, so for instance, the production function of manufacturers, this is the quantity of manufacturers that can be produced with land. So we can write it down very generally. So production function of manufacturers could be something like this. So QM equals QM. Here is the quantity of manufacturers that I could produce, say in Canada, which would be a function of how much capital I have and how much labor I have that works in the manufacturing sector. And what we're going to say is that this function has decreasing marginal returns in each input. So I'm going to give you an example of what this would be. So example of such function, just to give you an idea, is Cobb-Douglas. So QM. Yeah, so I don't have a capital M as so I can just write it this way, but it's something like this. Equals K to the 0.5 times L M the 0.5. So here that would be the scale of production would be constant, because if you double each factor, then you just double the production. But you see that if I keep the capital constant and I just put more and more and more workers working in the manufacturing sector, what do I see? I see that my production goes up, but by a lower and lower and lower amount, because here it's Lm to the exponent 0.5. So that's where the decreasing marginal returns come. It comes, so it's, yeah, it's the same for labor and it's the same for capital as well. All right, so yeah, QM is the economies output of manufacturers. K is the economies capital stock. And LM is the labor force employed in manufacture. One thing to see here also is that K is fixed. In Canada, we have certain amount of K, certain amount of T, and we can't change it. The only thing that we're able to change is how we distribute L between LM and LF, right? So same thing for food. So example of production of food would be K. If can I write it? Yeah, let's write it this way. KF would be QF would be something like T to the 0.5 multiplied by LF. Yeah, I can write it there. LF to the 0.5. So QF is the economies output of food. T is the economies supply of land, and LF is the labor force employed in food. Yeah, so if you look at the book, then unfortunately they don't. They have changed it, so now they use cloth and so yeah, they use the same example as before, but here I like using, so I hope you don't get confused. It's the last edition of the book, but I think I prefer that one, just looking at manufacturing and agriculture. So, but the idea is the same. And now, can somebody think of how I would write my constraint in terms of labor? Because I cannot have an infinite amount of labor. It's fixed with the population of Canada. And of course, I just produce two things. So let me write down what my question is. So think about, I'm just going to get my yeah, no. This is the production function of, so I've got somebody suggesting, when I talk about constraint, it's when I talk about constraint, it's it's a limit on the amount of resource or consumption or whatever. Here I have a limit on the amount of labor I'm able to invest in manufacturing and food production. How do I express this? If I tell you I have the total labor force of Canada and I'm constrained by investing my labor force either in the manufacturers or in the food production. So how would you write down such a constraint mathematically? It's not written there. It's just I want you to think a bit about it before I give you the answer. A hint, it's we've seen the same yeah, not exactly. So this is yeah. The important thing is constraint there. Or okay, so I'm just going to write it in some other no, not exactly. All right, so I'm just going to say it in another way. So maybe it's going to be more obvious. So if I use LM workers in manufacturing and the total workforce of Canada is L. What is the available workforce LF in the food sector or food production?
L minus LM.
Yes, good. Yeah, so that's what I'm exactly. So yeah, now it looks obvious and I express it this way. So here it's just saying that LF has to be equal to L minus L. Or another way to look at to say this is that LF plus LM equals L. So that's my constraint, in terms of production, right? So just that's the next slide, but I just want to keep your mind active. So yeah, so the full employment of labor conditions require that the labor must equal the labor employed in either sector. So LM plus LF equals L simply. So that's a constraint is always going to be written in this sort of way. It's I have the total amount I can use and I distribute it in either of different things. So here it's the total labor that I distribute either in manufacturing or in food. And then we can use these things to distribute to express the production possibility frontier of the economy. But before going there, let's just discuss a bit more about the marginal product of each things. So yeah, let's go ahead and do that. All right. So here is QM, which is QM of K and LM. And here I have the output QM on the vertical axis and the input LM on the horizontal axis. And so the assumption K is fixed. So that's not something that I can change. So I have, I don't know, 10,000 units of capital in Canada, and we don't change it. The only thing that we can change is LM. So it's good to look at how it's going to go. And what do you observe? Well, if I have very little, if little amount of workers, yeah, little number. Then in manufacturing, one extra worker produces a lot. And if I have many, then produces not that many, not much more, right? So that's the whole idea behind the production function for manufacturer. So if you want to look at it, so imagine, yeah, let's have this, right? So if I go from this amount to this amount, then the output increases a lot. But then if I keep increasing the amount of the number of workers in the sector, so I increase by the same amount, then you see that the extra gain from an extra unit of production is quite low, right? Makes sense? So this is all what we mean by decreasing marginal returns. And by the way, that would be exactly the same for capital. So if I said that labor is fixed and I'm increasing capital, then it's the same thing I would observe, is that the first unit of capital is very good because I have 100 workers and no machine. So if I give them one machine, it's super valuable for them and it increases a lot. but then 2 machines, 3 machines, 4 machines, and then when I get to 100 machines, then they don't have anything to do with it anymore. So it just gives me a very small amount of increase in production. All right. So this whole idea is the idea of diminishing marginal returns. So yeah, that's what I just said. So adding one worker to the production process without increasing the amount of capital means that each worker has less capital to work with. So therefore, each additional unit of labor adds less to the production than the one before. So here you have you have few machines per worker. Sorry, you have few workers per machine. So if you have more workers, they're much more productive. And here they already have the amount of workers is high. So if you add one extra worker, then the extra production is not that high. Yeah, so and then what we can do is show not the total production, but the extra production. So this means that I have a graph in which I show that on the horizontal axis, the labor input, and on the vertical axis, not the total output of manufacturing, but the extra output of manufacturing. And what do I get? I get this opposite curve here, which is the marginal product of labor in manufacture. And what does that mean? Well, again, that's as I was showing here. So here the extra product is high, and then if I go 1 unit more, the extra product gets smaller, and then 1 unit more, it's even smaller. So that's what this shows here. So if I show like one. One more, and one more. Yeah, so each extra worker brings less extra production. So this is what we mean by the marginal product of labor. All right. And now I think I'm going to jump to rather a graph to give you more of an intuition of what's going to be going on. Otherwise, it's a bit confusing if you. I think it's confusing to look at the slides by themselves without seeing how it's built. So let me just show that to you. So I'm going to just have a blank slate if you want. So. Okay. So what's going on? Yeah, let's take some place. Or maybe that's too large. Okay, that's good. So I'm going to build the production possibility frontier from from the marginal product in each sector. So on this graph, I'm going to show the number of workers employed in each sector. And here I'm going to show what this means for the production possibility frontier. So this is going to be the production possibility frontier. And here, this is going to be the labor constraint. So how much labor can I invest in each sector and what this gives me in terms of production? So how much can I get of labor? So I'm going to put here labor in manufacturing, or labor in food rather, and labor in manufacturing here. So what is the maximum amount of labor in manufacturing or the maximum amount of labor in food? Well, it's just the maximum amount of labor I have in Canada. So it looks like this, for instance. So here I would have L and L. So everybody sees what I'm doing. So so before I would have had a constraint that would have looked this way, for instance. Showing the amount of workers I can have in either sector. This would have been the number of workers in the food sector. This would have been the number of workers in the manufacturing sector. But here I just flipped it over, all right? So here, the more I increased here the number of workers, then the more I produced, that I put workers in the food sector. The most I can put is all of them in the food sector. And here, or I could put some mix. So here it would be like dividing the number of workers equally between the two sectors. And here that would be putting all my worker in the manufacturing sector. Makes sense? So this is, this reflects LF plus LM plus L. Okay. Just remove this to not confuse you. And now I'm going to discuss what this means in terms of production. So how much production can I produce by adding more workers in the manufacturing sector? How much workers can I produce by adding more workers in the food sector? Well, so yeah, let me do it like this. Let's have this in, say, red. And then the same thing happened here. All right, so here, just to remind you, what I had is the total output as a function of the total amount of labor. So here is QM, the total output in manufacturers, and this is QF, the total output in the food sector. So as you start here is, imagine I have 0 worker in the manufacturing sector. So my output is 0. Then I increase a bit my workers in the manufacturing sector, and you see that the output goes up and up and up and up. And here I can, this is what I get if I put all my workers in the manufacturing sector, I get this production here. Same thing on this axis. So on this axis, this is what happens if I put 0 worker in the food sector, then I start putting more workers in the food sector, then my output goes up and up and up, but you see that it goes up by fewer amount because of the decreasing marginal returns. And then the neat thing with this is that I can, if I add more workers here, then I reduce the workers here. If I add more workers here, I reduce the workers here. So I can deduce what is going to be my production in each sector. So let's just do that. So imagine that I start with putting half and half. So I'm here. How much production will I get in the manufacturing sector? It's this amount. How much will I get in the food sector? It's this amount. So it's going to look like this. And then I can have my here, right? Now let's have more workers in the manufacturing sector. So I reduce in food and I add in manufacturing. So I get this production in manufacturing and this production in food. So I get this there. Then let's add even more for the sake of it. So let's go extreme. And then let's have one more, but on the other side. So like here, for instance. This and this. And I so just able to get my version possibility from here, which looks like this. And this must be somewhere here. Does that make sense? Have you seen this sort of production possibility frontier before? Yeah? No? So this reflects the fact that you have decreasing returns in each sector. So it means that if I'm here and I want to produce even more manufacturing, so I want to increase the quantity of manufacturing, then my extra workers in the manufacturing sector are not super productive, so I cannot increase by a lot, but I have to sacrifice a lot of production in the food sector because I go from having like 10 agricultural workers to 5, so I have to sacrifice a lot. So this is the relative sacrifice that you have to go through to invest in more, to produce more manufacturing. So what would be the optimal amount? Well, we really see that the optimal amount is probably somewhere in the middle. So it's probably somewhere here or here. It would be surprising if it were here or there, for instance. That would mean that in Canada we produce only manufacturing and no food, or only food and no manufacturing. So of course it's probably in between. Yeah, these points there. And by the way, just to have a link with the last class. So question, how would we, or can we obtain a production possibility like in the Ricardian model? If so, how would we get that? What would you change to obtain a production function? By the way, it's not a super easy question, but it's very good to have your mind set to it. Think about it. What would you change? I give you 1 minute to think about it. By the way, so do you somebody remembers what the production possibility frontier looked in the Ricardian model? That's the first question. Nobody remembers?
Wasn't it just like a graph with the two goods? And then
Yes.
you had
So
the
what was
market
the difference between that one and this one we have here?
that here it's like a curve and the other one
Yes,
is the line.
exactly. So in the Ricardian model, we always had the same substitution between the production of one good and the other. And here it's curved this way. So how would I be able to generate a straight line for the production possibility frontier with this setting here? No clue. All right, I'm going to say it. So why is it straight in the Ricardian model? It's because whatever the production level, anytime I take a worker in one sector and put it in some other sector, the change in the output is always the same. It's always the same proportion. Why? So it means that the productivity of this extra worker is always the same. So how would you generate the same thing? Well, just by having the same marginal productivity for regardless of the number of workers. So I'm just going to draw it very quickly. So the answer, if marginal productivity is constant, not decreasing. And so that would look like this, for instance. And here, instead of having decreasing marginal productivity, I would just have a constant marginal productivity. And then something like this too. So like this, for instance, it means that however many workers I have invested in this sector, the extra worker gives me always the same extra production. And then what do I get if I have this? So I can just do the same exercise. So if I start by having half and half, for instance, then I would be here and here. So that would be 1 point. It's another point. Yeah, that is then oops, sorry. If I produce here, then I get this. And if I produce here, I get this. So you see that I'm going to generate a straight line. If my drawing is correct. Yeah, more or less. So you see that in a sense, what this means is conclusion, the Ricardian model is one extreme version of this model. So because in a way it's just I can have the curvature that I like, and if at the extreme I have a curvature of almost 0, then I get the Ricardian model. All right. So this model is more realistic in some ways. All right. Oh, we are already at 11 o'clock. So we can have a break and then continue with the rest of the model. How is that? And we are back. Okay, so let's see what we do with this. So now I'm just going to use this part of the graph. We're just going to know that we obtain this by shifting the labor in either the food sector or the manufacturing sector. So this is how we get this this separation possibility frontier. But now we're just going to use this one. And okay, so I could just do a very high level analysis of this, but I prefer taking our time and giving you some insight as to what's going on, because we have different production now. So I mean different resources to use in the production. So I think it's good to have some insight as to what's going on. So before continue, yeah. So let me just start by drawing again the real quick thing there. Okay, so just to remember, I put manufacturing on the horizontal axis and food on the vertical axis. Okay, so this looks something like this. And imagine we are in Canada. So in Canada, we have a lot of land to produce food and we don't have a lot of capital. So in general, we're going to be stuck not producing too much manufacture because it's expensive to do so. And we have to put lots of labor in it and it's expensive. So we rather produce more food. So how does that, will that look in autarky? It's going to look like this. So maybe we're going to be, let's say, here, for instance. And if we had, like a representative consumer in Canada, so that would look... like we could put some utility function there. So, no, that's not right. Yeah, that's better. All right, so let's label this U0. So that's and we can see we're at point A here. So yeah, I'm not going to dig into too much in it, but so I just say the following. So point A, if home Canada does not, so yeah, Canada has, let's have land to produce food. If home Canada does not trade, it will produce at point A. Let's food, not too so much manufacturing. Right, so the exact point depends on the utility function. So this is a sort of and yeah, the representative Canadian consumer gets utility U0. And now the question is, what is this? The slope here? So that one. This way. Yeah, I'll put this arrow here, it's better. So what is the slope at A of the, so this is the production possibility frontier, or let's put it here. This is the utility function. So first of all, is it positive or negative? So you have one chance out of two to get it right. Is this slope there positive or negative? Yes, negative. And what does that reflect? Well, it reflects the relative price on the Canadian market between manufacturing good and food. So here it reflects the fact that food is relatively cheap and manufacturing is relatively expensive. So if food was expensive, then the slope would be steeper. And I'm going to justify this. So the slope is going to be minus PM divided by, or it's PM divided by PF. Does that work? Yeah. All right. So this is the same thing as if it was consumer. Have you seen a bit the microeconomics with the consumer who chooses between good one and good two? Somehow, yeah. So you know that the slope and for the utility function is always the relative price. And so in the case of the consumer, we just have relative price, which are dictated by the market price and the budget. Here it's going to be the same. So I'm going to show you why this slope is minus PM over PF. So and probably we don't finish all the, maybe we don't finish all the model today. It's not too bad. I prefer taking our time And so going over what we have time to see, so you don't get too much, lost too much. All right, so share my screen. Yeah, so the factor model. So before we had, oops. So before we had the Ricardian model with one single production input, labor. Now we're going to have two input of labor, so two sectors. Manufacturing and food. So let's look at the product, at the profit. Let's start in manufacturing. So if you have a firm in the manufacturing sector, then the profit would be something like so you use two two inputs, capital and labor. So you would have that the profit, which would be a function of capital and labor, would be equal to what? So the revenue minus costs. So the revenue would be PM. And now that's the neat thing about this detecting is I can use the proper, so yeah, prices. I'm going to have three prices. So price of put, so PM, price of labor W, it's the wage rate, and the price of capital. I'm going to put this RK. That's the rental rate of capital. So I'm going to put RK because I need a rental rate for agricultural for the agricultural land as well. And the rental rate of agricultural land is going to be RL, all right? Or RT rather. Yeah, T for terrain. So this is why I need to specify which rental rate it is. So this is going to be Q, so the sales price times the quantity produced. So it's the quantity of manufacture, QM, which is a function of capital and labor, minus the input prices, so RK times K, how much capital I have times the rental rate, minus how much labor I employed, W, times how much labor I employed in the manufacturing sector. So of course I need to specify that this is in the manufacturing sector. And before, when I had the Ricardian model, if you remember, I just add L here, this was not there. And also it was a constant function. So I couldn't really optimize this properly, but now I can because I have decreasing returns to both inputs. So computing the optimal, or rather maximizing profit in the manufacturing sector. So So first order conditions. Optimal quantity of capital would be this. So I'm doing like if I were able to change my amount of capital. I said it's fixed. So in principle, I cannot, but in the long run, I can. So at some point, this has to be not to, the K has to be still chosen sort of appropriately. So if I do that, I PM DQM DK minus R, and then this derived by K, this is equal to 0. So I get that the rental rate RK has to equal to this. So the price times the marginal product of capital. So I can just write it this way. Rental rate of capital has to be equal to the price of manufacturing times the marginal product of capital. This is how I'm going to write it. So is price manufacturing times marginal product of capital. And sometimes you can write it this way too. So is the marginal maybe this way, value of the marginal product of capital. Yeah, let's just write the marginal value. Anyways, that's not super important. It's just sometimes you may look at you may hear this marginal value of capital or the marginal value product of capital. So of course what this means is that the extra unit of capital would cost me RK, but it has to bring me the same amount of input as extra profit or extra revenue, which is its marginal productivity times how much I get paid to produce. Similarly for labor, I would get simply this. So equals minus W. Oh yeah, so that's something I should, since I put LM here, yeah, I have to have LM everywhere. Zero. So then I get similarly that the wage rate is equal to the marginal value product of labor. So and then I'm going to write MP marginal product of labor in the manufacturing sector, right? So this is how I derive these things. And now, so this is the first sector. So in the manufacturing, so if I could do the same thing in the farming sector, then I would get that the rental rate of terrain, yeah, just to say this is so yeah. Okay, I'll do it step by step, not to to lose anybody. So 2 inputs. Now I have land or terrain, which is labeled T, and labor L, and then F in the food production. Price is the price of food. Output, which is PF. And the price of labor is the same. Why? Because there's free movement of labor between each sector. And the price of land. RT. Right. And I could, so I could do the same thing. So the profit is going to be the agricultural sector is going to be T. So that's just the land that I have available in Canada, the labor input that I have in the agricultural sector. So L food in the food sector, and then so the rest stays the same. Okay, and if I optimize, so I get the same thing. So I get similarly that rental rate of terrain has to be equal to the price of food times the marginal product of terrain. And the wage rate in the food sector has to be equal to the price of food times the marginal product of labor in the food sector. All right. So you're seeing that it's starting to look like the Ricardian model we had before. So we because since the wage rate has to be the same, so I get that the marginal product of labor has to be the same in every sector. So this has to be equal to this marginal product of labor in the value in manufacturing has to be equal to the value of in food output. So that. Right, so that's one thing. So this looks a lot like the Ricardian model. So it's a bit the same thing. It's the relative price has to be equal to the relative productivity. That's because there's free movement of labor, and of course workers are rational, and they're going to go where they're paid the most. And the firms are rational, so they pay each input up to their marginal productivity. All right. So yeah, this reflects this. So the way to get there is, I would say, is more natural, because that's the way we think about things. So we maximize profit, and we find these optimality conditions. Same thing, we maximize profit and we find these optimality conditions. So that's more accurate. All right, so now going to what I was talking about. So the slope of the production possibility frontier. So what is it? It's delta QM divided by, is it, what did I put in the, I put QF, the QF divided by delta QM. All right. So the production possibility frontier is how much quantity of food do I need to sacrifice to increase 1 unit produced of quantity of manufacturing. Oh, by the way, I've been doing a lot of computation. So I could have done much less. I could just have pulled these equations out of my hat. So it's a dilemma for me. So should I show you less, but then you just have to learn stuff by heart? Or for some of you who are more advanced with these things, would you like to know where they come from? So I'd rather show you more detail, and so you know how economists think about these things. So yeah, so that's how we get them. All right, so here is so going back to the slope of the production possibility frontier. So if you remember correctly, I'm just going to show you briefly what this looked like. Yeah, so that was it, right? So the slope of the production possibility frontier is how much do I need to sacrifice in quantity of food if I want to increase 1 unit of manufacturing, right? So so this is what we're after. And we want to show that it's minus PM divided by PF. All right, so going back to the computation. So it's delta QF divided by delta QN. And how do I know what this is? Well, how do I get 1 more unit of food, knowing that I cannot increase the amount of terrain I use? So if I were to ask, if I'm the Prime Minister and I ask you, I want more food, what should I do? What would you reply?
Hire more people to work.
Yes, exactly. Exactly. So delta QF would be equal to, so it's what is the marginal product of labor in the food production multiplied by this extra people that I hire, so the delta N. And here that would be the amount of manufacturing that I would have. Yeah, so that's the amount of food I would sacrifice, and the amount of manufacturing I would get is the marginal product of labor in manufacturing sector times the, oh yeah, so sorry, delta F, yeah. All right, and now what can we do with this? Yeah, so do we do you remember something? So this is so we've just seen that since wage are mobile between each worker, each sector, then the ratio of MPLF, MPLM is the ratio of the price in each sector. So I can just substitute this. So I get this. All right, but now I still have that these two numbers there. So is there some way to maybe substitute one in terms of the other? Can you think of where that would come from? I leave you a couple of seconds to think about it. So I want to increase my production of, oh, this is, yeah, okay. So I want to increase my production of worker in the food manufacturing sector. Right? Then to do that, I need to, what do I need to do in the food sector? No clue. Can I can I get workers from some other country to produce more manufacturing? Yes, but no, I said no. I said Canada has just a limited amount of labor. Yeah, it's true that it's often what we do. We have foreign workers who come work, especially in the food sector. Actually, in the yeah, now we're going. We have some chicken catchers that we can't have. So we're short of chicken catchers right now because normally they come from Latin America. But yeah, now we assume that we have just the same number of workers. So is there some link between delta LF and delta LM that I can take advantage of?
Can we not use this whole labor equation and then solve it in one direction? No, so for one variable and then use it in this one.
Yes, exactly. So in one word, if I add one worker in the manufacturing sector, what does that mean for the food sector?
Decreases by one worker.
Yes, I lose one. So let me just show you briefly what this means. So labor constraint. So I have that LF plus LM plus L. So simply I have LM equals LF divided L minus F. So if I want to increase the amount of workers here, I have to, this is 0, it doesn't change. So I have to decrease one worker here, simply. So what do I get? Get that delta QF divided by delta QM. So I can just, let's substitute delta LM. So it's minus delta LF. So what do I get? I get, so this cancels out with this. And here I just have a minus in front. Right, so this is what we wanted to show. All right, so okay, so this is just to show you what the slope is, to really show that it's still the ratio of the prices in each sector that determines the slope of the production possibility frontier. So let's go back to it. So it's indeed minus PM divided by PF. And then what happens if, if Canada starts trading with the US? So what did we say? Well, I don't know exactly what the situation in the US is. I would need some to do the same thing in the US. But basically what we know is that in the US, they have more capital compared to the amount of land that they can use for agriculture. So it means that so the price of food is going to be higher compared to the price of manufacturing. So in the US, price of food is higher than the relative to manufacturing than in Canada. So I get that the slope. So what is going to be the price at which we trade? Well, it's going to be in between. So here minus PM over PF is quite horizontal. In the US, it's going to be quite vertical. So when we start trading, probably it's going to be in the middle somehow. So what we're going to say is that the international price will be like in between the relative price in Canada and the US. So what we can see is, so we're going to see that, so we're going to use asterisk for this. So this is going to be a bit bigger in the US than in Canada, or internationally than in Canada. Or rather, it's smaller because it's negative. So what this is going to look like is probably the ratio is going to look like this, for instance. So international price. Of course, that's an assumption. So I don't know exactly where this is going to be. It depends on the relative demand in each country, and it's like the Ricardian model. But yeah, we can basically say that it's going to be, so imagine that in the US, it looks like this. So here it's going to be a bit in the middle. Right? So and so what will Canada do? Well, no. Canada can produce so I'm going to say that, for instance. So this is the new production that we can use, since the relative price is more like this. And sell on the international market. So we can sell and then we can get this to this point. So let's put this C. And then we can get this better utility function. So this was U0, and this will be U1. And then I can even show how much we produce. So here that would be QC. So QC of manufacturing. Right. No, I'm having some doubts about me. Just think a second. Yeah, I think I made it like if Canada was. I'm just having some doubts about what I just did there. So the only question I have is, should I have started with A here and yeah, concentrate there rather? Yeah, I'm going to leave it this way anyways, that's good. The only thing I have in doubt is my story about Canada and the US right or not? But anyways, this is right, so I'm just going to leave it at that. Can consume C. So can somebody tell me what are the import? So after train, so yeah, so imports or Canada. Let's start with exports. In that case. Can you tell me on this graph what's happening?
So I think that in the beginning, Canada was producing A, so they produced a lot of food goods and less of manufacturing because it was cheaper for them. But now that they entered trade with the US, the production costs for them reduced, or not necessarily the production costs that there, I'm not sure, but they have the ability to produce more of manufacturing, and the surplus they have in the food they can sell on the international market, which leads overall to a higher indifference curve that they can reach, which is C.
Yes, so exactly. So I think my graph I flipped it. I think in my original example, so I'm really sorry for. Okay, we'll leave it at that, but I started the class talking about Canada because I thought it was a good idea, but now I think my graph is flipped and I haven't realized it. Yeah, what could I? Okay, let me just take 5 minutes to change it a bit. Right, okay. So I'll just change this because it's going to make more sense this way. A and B. And yeah, never change your examples midway because it's everybody gets confused. All right, so this would be here. This would be here. Then this is B, and then this is C. Okay, this makes more sense. And then this is the international trade. So this is U0. And this is U1. Here it is. All right. All right, so okay. So because of course Canada has to export food, right? So otherwise it doesn't make sense. Yeah. So this is yeah. Okay. This is QC, QB. QC, QB. All right. So now this makes more sense. Canada exports exports what? Exports food. And the quantity is QFB minus QFC, because QFC is what Canada consumes, and QFB is what Canada produces, right? So and Canada imports manufacturing goods. So that's QFC, QMC minus QMB. Yeah, that makes more sense. Okay, so what happened here? What's the story there? Well, the story is that Canadians like manufacturing good. They like food, but not that much. But the problem is they don't have a lot of capital. So what they have is to put lots of workers in the manufacturing sector initially. So yeah. So before trade. Canada must put many workers in the food sector to produce manufacturing. Inefficiently. Because we don't have a lot of capital after trade. Canada can concentrate on its advantage. Agriculture and export agriculture. Yeah, food, export food. And import manufacturing. Products. And export food and import manufacturing products. All right, so that makes more sense. Sorry about the confusion. I changed my, I had to flip my graph because I tried using a better example. All right, did I miss something? Yeah, I think not. I think it's all right. Any question on this? So this is the basic idea of gains from trade here. It's you concentrate on what you do best. Canada, it's on food. And then thanks to that, we can consume a better amount than we could. Before we were stuck at 8. So, oh yeah. So the gain from trade. U1 is greater than U0. So more consumption of both products. And yeah, here this is so this is different, right? So the slope is less shallow, so this is larger than this, or in absolute value, yeah. Okay, so yeah, in the last few minutes, I think I'm going to go on the slides again, just to wrap up what we have discussed so far. We still have to discuss who gains, who loses from the trade. We're going to continue this next time, so don't worry about this. I'd rather go slowly and step by step so we can see where everything goes. All right, so going back to the slides. So this is the the whole production possibility frontier derivation, but I think it's, yeah, just showing you this right away, it's just such a mess for the eyes that it's complicated. But yeah, you see everything. So here is the allocation of labor. This is the production function for manufacturer, production function for food, and the resulting production possibility frontier, as we've seen so far. So then the question is, how much labor will be employed in each sector? To answer we need to look at the supply and demand of labor in the labor market. And so the demand for labor in each sector, so there's profit maximizing employers, as we've seen how they maximize profit. So they will demand labor up to the point where the value produced by an additional person hours equal the cost of employing that that person. And as we've said, it's so the wage is going to be equal to the price of manufacturing times the marginal product of labor in manufacturing, and it's going to be equal to the price of food times the marginal product of labor in food sector. Oh yeah, so that's that's here right here. So marginal product of labor in the manufacturing times price of manufacturing is wage. And it's also going to equate the wage in the food sector, right? And the wage rate must be the same in both sectors because of the assumption that labor is freely mobile between sectors. Yeah, so the wage rate is determined by the requirement of the that the total labor demand is equal to the total labor supply. How much time do I have? Yeah, 8 minutes. All right, I can go on and draw the equilibrium on the labor market real quick. And then we can continue there next time. So now we assume that we are not open to trade, okay? So we start with this, but then we are going to open to trade. So how are we going to illustrate what determines the wage rate? We're going to use a graph in which we show both the labor used in manufacturers and the labor used in the food production. So here's how we are going to do it. Oops. All right. This is wage rate. And this is the real wage rate. True, of course. And here I'm going to have my labor force. And the thing to express the fact that the labor is fixed. So the size of this is L. And what I'm going to do is increase the labor force this way to put more workers in the manufacturing sector up to here. This means that I have the whole labor force in the manufacturing sector. And if I'm here, it means I have the whole labor force in the food sector. So so what happens to the wage rate if I in the if I increase the amount of workers in the manufacturing sector, what happens to the wage rate in the manufacturing sector? Goes up or go down? Maybe it's a bit late. Yeah, okay. So I think we can stop now because your brain is already melting, and we can continue here next time. So next time we're going to see how everything changes with the when we open to trade for terrain owner, for capital owners, for workers and everything. All right. So before we leave, are there any questions about some aspect of the class or so I just want to say a general comment. I have the feeling that the class is maybe a bit advanced for you, or yes? Okay, because so as I said, I decreased the level of difficulty compared to last time. So maybe it's still a bit high. So yeah, so that's why I'm taking my time. We're going to see the number of models we can see in the time I think is relevant. But I think it's good for you, for this class to be I plunge you into how economists think about the world, how we model things, and how we can apply our intuitions and our formalism to answer some economic questions. So I don't want to make you professional economists. That's not the goal. But yeah, that's going to be the goal. So seeing how things are not necessarily super easy for you, I think it's best not to see maybe all the chapters I was playing and seeing, but at least the chapters that we do see, we see them well. All right.
Yeah.
Because I don't want to give you nightmares.
No, I think it just depends on people because I don't have an economic background. So for me, all this is new. So yeah, that's why.
Yeah, so it's by the way, it's having your camera on is just so useful because if I just have black screens everywhere, I don't know, maybe I just have PhD people on the other side and I have no clue, so I can go very fast. But yeah, so just seeing that, oh, maybe I'm not sure, I don't know this or that, so that's a good sign for. So basically what I'm saying is don't turn off your camera. Oh, by the way, I think this time is the last time that we do this online, right?
Not sure.
Yeah, I think you can they go back in person if I'm not mistaken. It's 30th, right? 30th is the last day. So 31st. Yeah. So I'll just confirm to you, but I think we're in person next time.
Okay.
All right, so we're going to
Better.
continue here. Yeah, I think it's going to be better because I have to flip many different screens. But in a way, it's good because I keep track of all my models, and you can keep track of everything. You don't have to struggle copying everything. So I think it's a neat way of teaching. But yeah, I'll think of how I manage my things next time.
Because
all
you
right,
can
so
rewatch it, so it's fine. Like
yeah.
I used to rewatch it. So
okay. So thanks everybody, and I see you. Oh, and by the way, so let's just say that everybody agrees with the evaluation stuff, and so the two people who said that they would send me an email, please send me an email and say it's okay, so I can just put your name on it and yeah, get okay. So thank you everybody.
Thank you. Have a nice day.
Have a nice day.
Thank you.